All right, so as we stated before, our first step is going to be creating our ice table. So we're going to have our silver bromide right here on our left, our NH3 solution that we are dissolving it within, and then the formation of our complex ion and the leftover bromide. So remember, we started with 1 molar of NH3. Here, AGBR doesn't count because it is a solid, so therefore we are not going to be using it in this part. We started with none of the reaction because remember, we're starting with adding this to that, so none of these have formed yet. So we start with an initial concentration of 0 and an X amount for the end concentrations. So remember, so since we have 2 moles of this, we will be this will be decreasing by 2 times X amount of whatever is occurring here. So we're going to find out what these values are. So now what we're going to do is we're going to create a new K, which makes sense because we are looking not only at either of these, but looking at both of them because we're looking at the formation of the constant and the KSP, which includes our silver ions and bromide ions. So from here, we can use our givens, which remember are 5 times 10 to the negative 13 of our, which is our KSP for AGBR. And we have our 1.6 times 10 to the 7th, which is our KF of our complex ion that we have been given. And from this, we get 8 times 10 to the negative 6th. So we get, so now, with this in mind, and the previous slide in mind, we can create our K equation, which is pretty cool. So we now have our complex ion, which is, we have our products right here and our reactants right here. So we have complex ion and the bromide ions that are left over at the end of the equation, and our NH3, which was the solution that we put the solid AGBR in. Remember, we don't include AGBR because it's solid. This is not, we're looking at the solution, we're looking at solubility equilibrium. The solids don't count. All right, so now we take our awesome new K and we can plug it in to our this equation right here. So we have X amount of our complex ion, which is Ag NH3 to the 2, and our concentration of Br, which is X as well. And then we have our 1 minus 2X of our 2NH3 to the 2, because remember, we had 2 moles of this, all right? Okay, so now all we got to do is solve. So since we have our 2 x's here, we can combine them to get x squared. And what was really good about this equation is that we could square root both of these equations because we have both of these are squared. So that left us with 2.8 times 10 to the negative 3, which is equal to x over 1 minus 2x, all right? So from here, what we did was we multiplied our left side of our equation here by the denominator of our equation over here. So we had 1 times 2.8 times 10 to the negative 3, and then 2x times that as well. So this is what we got when we multiplied 1 by it, and this is what we got when we multiplied 2x, and that is all going to equal to x. So now we're going to divide by x. So once we rearrange that, we're going to get x is equal to 2.8 times 10 to the negative third minus 5.7 times 10 to the negative third. And this will give us 2.8 times 10 to the negative third moles of AGBR is going to dissolve because we have a negative value of this. So it means we're going to lose this moles of AGBR as they dissolve and join into the making of our complex ion. All right. I hope this helps you guys study for the test, and good luck with the upcoming final.